Hey, what's up? Welcome to my channel. So today we will discuss the exercise on binary operation. So here the first question is, state which of the following sets are closed under the operation addition, subtraction, multiplication and division. So there are some sets R, that is set of real numbers, Z set of integers, set of natural numbers, set of rational numbers, whole numbers, complex numbers and real numbers excluding the zero. So we have to check whether these sets are closed under this operation addition, subtraction, multiplication or division. Now for the set of real numbers, since for any two real numbers the sum of these two real numbers again belongs to the set of real numbers. Therefore, this set R is closed under the addition. Therefore, R is closed under addition. Again, if we take two real numbers and their sum, their subtraction is always a real number. So for any two real numbers, the subtraction or the difference of these two real numbers a minus b again belonging to the set of real numbers. Therefore, R is closed under subtraction also. Similarly, if we multiply these two real numbers, again multiplication of these two, a into b again a real number. Therefore, multiplication is also closed, that is the set is closed under multiplication. Therefore, R is closed under multiplication, and obviously R will be closed under division also. So this is the set R which is closed under all these operations addition, subtraction, multiplication and division. So first one is closed under all of these operations. Again, Z, that is set of integers. We all know what is a set of integers: 0, positive numbers and negative numbers, all together called set of integers. So for any two integers, addition of these two integers will be again an integer, subtraction is also belong to the set of integer, multiplication of two integers is again an integer, but the division of two integers cannot be an integer always. It does not happen always. Let us take any two integers from the set Z. Suppose 10 and 2. Both are integers. Now 10 by 2 equal 5. Right? And 5 is an integer, no doubt. So here division is occurring, but sometimes for some numbers this operation does not follow always, because if we take 1 and 2 and if we divide 1 by 2, that is 1 divided by 2, this is 0.5 or the fraction 1 by 2. So the fraction 1 by 2 or the value 0.5 is not in the set of integers. Therefore, division is not satisfying here. Therefore, the set of integers z is not closed under division. Therefore, the set z is closed under addition, subtraction, and multiplication. So it is closed under addition, subtraction, and multiplication. Right? Now, the set of natural number n and we all know what is the set of natural numbers. This is 1, 2, 3, 4, 5 up to infinite terms. Now, if we take two elements of this set and sum of these two elements will be again in the set, right? Since the set of natural numbers, if I take 3 and 4 and their sum is 7 and 7 is in the set. Similarly, if we multiply these two numbers, 3 into 4 equal 12 and 12 is again in the set, right? But when we divide 3 by 4, this is a fraction, but this number is not included in this set of natural numbers. Therefore, the set of natural numbers n is closed under addition, multiplication, but not division. Similarly, if I take 3 and 4 and subtract 3 minus 4, that is minus 1. Again, minus 1 is not a natural number. Therefore, the set of natural numbers is closed under addition, multiplication only. Closed under addition and multiplication, right? I hope this is clear. Now to check the other sets. Now for the set of rational numbers, when we take two rational numbers and add these two, then it will be again a rational number. So addition, it is closed under addition as well as subtraction, because if we take two elements of this set Q and if we find the difference of that elements, then it will be again a rational number. Multiplication is again a rational number if we take two elements A and B belonging to Q. So the multiplication of A and B again belongs to Q. As well as if I divide these two numbers, it will be again belonging to the set of rational numbers. Therefore, set of rational numbers is closed under addition, subtraction, multiplication and division. Now the set of whole numbers. Whole numbers are nothing but starts from 0, 1, 2 up to infinite numbers. So addition will be again a whole number. So it is closed under addition. But sometimes the subtraction is always not occurring, because the difference of these two elements 1 and 2, the difference of two elements 1 and 2, it will be minus 1, and minus 1 is not a whole number. Therefore, W is closed under addition but not in subtraction. So, and W is closed under multiplication also. It is closed under multiplication because if I take any two elements from this set and if I multiply those, then it will be again in the set of whole numbers W. Again, the set W is not closed under division. It is not closed under division because 1 divided by 2 is 0.5 and 0.5 is not in the set. Therefore, W is closed under addition and multiplication only. So W is addition and multiplication only, right? So we are done up to here. Now to see the set C, that is set of complex numbers. Set of complex numbers. So here definitely C will be closed under addition. Addition of two complex number is again a complex number, and C will be closed under subtraction. Subtraction of two elements of C is again a complex number, and multiplication. So the set of complex numbers C is closed under addition, subtraction and multiplication, but not in this division, because division of two complex numbers is not always a complex number. Now this last set, this is nothing but the set of real numbers but excluding the number 0. So for r minus 0, it is definitely closed under addition, multiplication, and it is closed under division. The set R excluding 0 is not closed under closed under subtraction. It is not closed under subtraction because since I take the elements 1 and 1, and if I subtract this, then it will be 0, and 0 is not in the set because r minus 0. Therefore, subtraction is not occurring here. Therefore, r minus 0 is not closed under subtraction. So, finally, what we have got, the set of real numbers is closed under addition, subtraction, multiplication and division. Similarly, Z is closed under addition, subtraction and multiplication. N is closed under addition and multiplication only. So W is closed under addition, subtraction, multiplication and division. Q is closed under these operations, and W is closed under addition and multiplication only. Set of complex number is closed under addition, multiplication and division. And the last one is closed under addition, multiplication, division, but not in subtraction. So I hope this question is clear to you. So proceed to the next question. Now the second question, does the operation star defined below on the given set represent a binary operation? So we have to check on these three questions whether this operation star is a binary operation on these definitions. I am not writing the number 1 here because I have already discussed number 1 in the examples of binary operation in the last class. So from number 2, a star b equal a minus b on z plus. So the solution will be, since z plus is nothing but the natural number, z plus includes number 1, 2, 3 up to infinite terms. And here 0 is not included because 0 is a neutral number. This is neither positive or nor negative. Therefore, z plus includes this. For any two z plus numbers a, b, we cannot get a minus b belonging to z plus always. It cannot happen always. So A minus B does not belong to Z plus. For example, 2 and 3. If we subtract these 2, it will become minus 1, and minus 1 is not belong to Z plus. Therefore, star is not a binary operation on this definition. So, I am writing the example again here. So, star is not a binary operation BO on Z plus. Now the second question, that is number 3, A star B equal AB on Z plus. So it is very obvious for any two numbers A and B belonging to Z positive integers, set of positive integers, AB is always belonging to Z plus, because for any two positive numbers their multiplication is always positive, therefore it belongs to Z plus. So star is a binary operation on Z positive. Now number 4, A star B equal A plus B by 2 on the set of natural numbers. So for any two natural numbers, A plus B always belongs to the set of natural numbers, but their division by 2 is not belonging to this set, because if I take two numbers from n, 1 and 20, now their sum will be 21, and division by 2 is 10.5, but 10.5 is not in the set of natural numbers. Therefore I am writing here, star is not a BO on n for this definition, right? So these are the questions from question number 2. We have to check whether star is a binary operation on the given set from these definitions. So I have done here. So I hope these are all clear to you. So our today's last question is, so the question number 3 is, let A be a set including the elements 1, 2, 3, 4 and 5. Write the operation table on the set A for the operation this cap, where A cap B equal minimum of A comma B for all A B belonging to the set A. State whether these are BO or not, whether this operation is a binary operation or not. So first of all, we have to write the operation table. So how to write the operation table for a binary operation? I am showing it here. We are given A cap B equal minimum of AB for all these elements A and B belonging to this set, given set. Now the operation table is like, how many elements in the set? A, 1, 2, 3, 4, 5. 1, 2, 3, 4, and the last one is 5. So the given operation I am writing in this corner. Again I am writing the numbers of A, 1, 2, 3, 4 and 5. I am making the grids. So done. Now the elements, for the elements I have to take these elements. First of all, 1 with 1, 1 with 2, 1 with 3, 1 with 4, similarly 1 with 5. For the element 1, 1, it will be minimum of 1 will. Since the number 1, 1 is same, therefore minimum of them will be 1 only. So it will be 1. and minimum of 1 and 2, it will be 1, right? So I am writing it here. 1 cap 2 is 1. 1 cap 2 is 1 because minimum of 1 and 2 is 1. So this obviously will be 1, minimum of 1 with 3, 1 with 4 and 1 with 5 will be 1 only, right? This is clear. Now 2 and 1. 2 cap 1 is what? Minimum of 2 and 1. So it will be 1. Minimum of 2 and 2. Since these numbers are same, therefore it will be 2. Minimum of 2 and 3, 2. Minimum of 2 and 4, 2. 2 and 5, 2. 3 and 1. 3 cap 1 will be 1. 3 cap 2 will be 2. 3 cap 3 will be 3. 3 cap 4 will be 3. And 3 cap 5 will be 3. Again, minimum of 4 and 1 will be 1. Minimum of these elements with 4 will be the minimum one. 1, 2, 3, 4 and here 4. Now 5 cap 1 means 1. 5 cap 2 means 2. 5 cap 3 means 3. 5 cap 4 means 4 and 5 cap 5. Minimum of 5 and 5 equal 5. So this is the operation table for this definition. I hope this table is very clear to you and this is very easy. So I hope the operation table is clear to you. Now we have to check whether this operation cap is a binary operation or not. So see here, the minimum of these elements, with these elements, that is the elements of A, are the results. These are 1, 1, 1, 1, 2, 2, 2, 1, 2, 3, 3, 1, 2, 3, 4, 4, 1, 2, 3, 4, 5. So finally the elements are 1, 2, 3, 4 and 5, which are again belongs to the set A, right? Since by definition of binary operation, for any elements belonging to the given set, if the operation on these elements again belonging to this set, therefore the operation is a binary operation. Therefore from the table it is clear that cap is a binary operation here. So I hope this is done, right? So today's class is only about this. So I hope this is clear to you. And if you have not subscribed to my channel yet, then please do subscribe to my channel. And thank you for watching this video.